Hello, my name is Rob Reynolds. Welcome to Business Calculus, Chapter 5, Section 5. Today we're going to learn the area of a region bounded by two graphs, and we're going to learn that all you need to do is take the upper curve and subtract off the lower curve. It doesn't matter what it looks like. Here's the upper curve in red, here's the lower curve in blue, and it's always upper minus lower. There is one problem, I think, in your homework that you're going to do the right curve minus the left, but usually you're filling up the area left to right. So here's the lower bound, and then here's the upper bound. But there is one problem, upper, let's spell upper right. There is one problem, I think, in your homework that they don't give it in terms of see, this is x equals y. So if it says x equals and it doesn't say a y equals function, and it says x equals, I think they're hinting to you. They want you to do the integral of the right minus the left. And I'll talk about that real briefly and maybe help you out with that homework problem. So the area is bounded by the two graphs, consumer and producer surpluses, and some application problems. So again, area bounded between two graphs. Why can we always take the upper minus lower? Why does it always work? Well, if this is the area that we're trying to find between the two graphs, the area under the upper would be all of this, and you're going to subtract off the area underneath here, and you can see if you subtract off this area, that gets you the area between. So that's why area upper minus lower gives you the area between. And then you can read through more explanations here and here. Here it is. There's the upper, there's the lower. There's the f at x minus the g at x function. So here comes our first example. We don't know who's the upper and who's the lower, so it's probably good to draw a quick little sketch of this thing. This is a parabola. Kind of looks like this. We'll call that the we'll call that y sub 1. And then y sub 2 is an old boring line that looks something like the rise 1, run 1. So probably doesn't even intersect here. And we want to find it between 0, which is here, and 1. Well, let's find a couple points. We know 1, 1 is a point, and we know on this function, if we let x be 1, 1 squared plus 2 is 3. So 1 comma 3. So it looks like the area is right here. I should have made my graph a little bit bigger. I'm kind of scratching. So it looks like the area between is this in red. So I'm going to do the upper function, which looks like the parabola. So I'm going to integrate upper minus lower. And the upper is the x squared plus 2 minus the lower function, which is x. And integrate 1/3 x cubed minus 1/2 x squared plus 2x, and evaluate that using the fundamental theorem of calculus, which we learned in the last video lesson. If you need reviewing on that, you can. And then you number crunch this. Find this. Honestly, I would just go to your calculator. There's a couple ways you could do this. You could type this under your y equals, look at the graph of this thing, and then trace 1, enter 1.8333 minus the 0 is 0. And another way to do it is to go under your table setup and make sure you have ask instead of auto, and just looks like I had some other values in there, but there's 1 and there's 0, so there's that 1.833. I can delete that out. So you can either do table setup or just trace it. And I believe if I math enter this, I get 11.6. Which is the exact answer. Here's how the author worked it out. Again, they didn't show the f of a minus f of b, any work in there, but that's the fundamental theorem of calculus. Here comes example number 2. Again, the tricky part probably is to graph this thing. So negative x squared plus 2 means I start here at positive 2 and I'm swooping down this time for y sub 1. And y sub 2 is the line y equals x again. So we'll call that y sub 2. So this time the area between is here to here. So I got to find these points of intersection. I'll call that A and B because I'm going to integrate from A to B, lower to upper. And to find the points of intersection, pretty easy. All I'll do is set the two functions equal to each other. Let's set it equal to 0 by bringing everything over, plus x minus 2. Factor, looks like 2 and 1 are going to be some pretty good factors. Plus and minus, so x equals negative 2 and x equals 1. So I know this is a negative 2 and I know this is a 1. So I'm going to integrate from negative 2 to 1, the upper function, 2 minus x squared, minus the lower function, and I'll integrate negative 1/3 x cubed minus 1/2 x squared plus 2x, and do the fundamental theorem of calculus between f of negative 2 minus f of 1. I'll go to my calculator and find out that the answer is 9/2. Wow, my pen is really being goofy. Here's, yep, author's solutions. Example number 3 says it's bounded by the x-axis, so I'm going to graph this function. I know it's a parabola facing up, but maybe I can get a little bit more hints by factoring this thing. So 4 and 1 are factors that differ by 3, and I'm going to go x minus and x plus, so I know I've got an x-intercept at negative 1, and another 1, 2, 3, 4 x-intercept. I've got a y-intercept here at negative 4, and that's 3 points. 1, 2, 3, 4, I didn't find the vertex, but boy, I think it looks something like this. Of course, I could always do the negative b over 2a to find the x-coordinate of the vertex. There's lots of ways you could graph this, or just go to your calculator. But the important part is I'm looking for the area here to here between the x-axis. So I know the x-axis is a 0. And I've found the negative 1 to 4. That was nice that I factored that thing. The upper is a 0 minus the lower. Now remember, it's not just minus the first term of the lower. You're going to have to distribute that negative to every term. So you're really integrating negative x squared plus 3x plus 4 between negative 1 and 4. So negative 1/3, that seems like I have that a lot here, plus 3/2 x squared plus 4x, evaluated between negative 1 and 4, and that'll turn out to be 125/6. Here's author's solutions. They did the same thing. They factored, they graphed it, they set it up exactly like we did, and evaluated, and got the same solution. Sometimes we have graphs that intersect at more than one point. I don't know if you have like this function and then here, so I've got several points, and maybe I want to find the area from 0 to way over to this point. So you can see I have a little bit of upper here, a little bit of upper here, and then this area is actually below. So I'd have to integrate from A to B, and then B to C, and then C to D. So this would be several integrations. So let me show you an example of where they might have multiple points of intersection, hopefully not that many. Again, I would go to your graphing calculator at this time and graph this. Type in your f at x to your y sub 1, your g at x to your y sub 2. I'm going to zoom 6 to get a standard graph, and that looks pretty good right there actually. I could play around with my window. I don't need to see quite so far left and far right. And there's a little bit better view of it. But you can see that I've got multiple points of intersection. So I'm going to have to find the area between the curve. You can see the upper here is the f function, and then the lower is the g function. And I've got this yellow section in here, and I've got a blue section in here where the upper and the lower actually switch. So I need to find these points of intersection. This looks like a 0, but I'll just go ahead and set the functions equal to each other. Actually, do you know how to do this on your calculator and find points of intersection? Let's go back to my calculator. Second, calculate the intersect, which is number 5, and just choose one function, the other function, and I'll just give a good little guess right over here, and it gives me, there's the point of intersection, -2. You can look at the y value, but I'm interested in that x value. I'll repeat that again. Second, calculate number 5. Just identify the two functions. I'll choose the blue, I'll choose the red, and my guess is 2. So I'll just hit 2 and it takes me there. Yep. So now I know that I'm going to be integrating from -2 to 0. The upper function is 3x cubed minus x squared minus 10x minus the lower function, which is really just -2 if I simplify this, 3x cubed minus 12x, because these terms look like they will cancel after I distribute the negative, right? And so there's the upper minus lower, that's the yellow, and I'm going to have to add in the blue. And the blue is integrating from 0 to 2 by finding the point of intersection. And then I'll do again upper minus lower. And this time I'll get plus 12 because the upper was this guy. So it's -x squared plus 2x minus all of this, 3x cubed plus x squared plus 10x. So once again, the x squareds cancel, and I'm left with this term. Okay, so I think I've set it up correctly, and I'm ready to integrate. So 3/4 x to the 4th minus 6x squared, evaluated between those two, plus -3x 3/4 6x squared from 0 to 2. I'll apply the fundamental theorem of calculus. Well, that's easy. There's my 0 minus 0. There's the f of 0 minus f of -2 is what I'm going to do next. So plugging in a -2, I get 12 minus 24 plus, I'm going to do the same thing over here, but this time it's going to be f of 2 minus f of 0. So, of course, this is going to be 0 minus 0. That's, or 0 plus 0, whatever. But this is -12 plus 24. I'll add all that up, and I believe it gives me 24. A bunch of things cancel there. So again, here's how the author has worked it out. Hopefully you're going to Blackboard and you're downloading. Good, that's the image that our calculator gave us. And you can download the worksheet. Here's the setup. And they also got 24. Oh, they showed nice work as well. Here's that problem from your homework assignment. So you can see they have this f of y, which is really an x equals a y squared. And then they have another x equals y plus 20. Don't solve those for y. Leave those in this term. And instead of doing upper minus lower, you're just going to do the right function minus the left. And the right function is going to be that y plus 20 minus the left function, which is this guy. And then to find your, you're not going to integrate from, well, you're still going to integrate from a to b, but your a to b is not going to be left to right. It's going to be this lower. So there's your a. So you got to find this point of intersection, and that y value is your a, and then find this point of intersection, and that y value is going to be your b. So instead of finding your x's, like we did in the previous problem, from left to right, where this was my A, and we're moving over this way, filling up rectangles this way, A to B, going that direction. In this one, we're filling up rectangles going this way, from bottom to top. So you can practice that. Hopefully there's a nice little video on that. And so you need to find, again, those points of intersection, which your calculator will find for you, but just pick the y values, not the x values. A couple application problems. You guys are business majors, so you know about these supply functions, the demand function, consumer surplus, and producer surplus problems. You've seen this graph certainly before. Well, we're going to use it to find the yellow. You're going to do the demand function minus the price. To find the pink, which is the producer surplus, to find the pink area, we're going to do the price minus the supply function. So these are some definitions that you're going to need to know. I assume you know them because you're business majors, but I don't think you've ever integrated to find that area before. So again, I don't know if there's going to be a cheat sheet or not, but let's assume that you need to know those definitions for consumer surplus and producer surplus. And there's the written words for it, but you can see we're going to have to find the price. So I give you a demand function and a supply function, and the price is given for both, but I'll set those equal to find the price. So or to find the x and the y at least. So I'll set these two functions equal to each other, and I'll solve for x, and x turns out to be, I believe, 14. And then I'm going to take that 14 and either plug it into the price of the demand or the price of the supply, it doesn't really matter, and solve for y. So the y is the 14% times 14 plus 2 more, which I believe in this problem turns out to be about $3.96. So it doesn't matter, it should turn out to be $3.96 for this one too. But I think my price, which I had to calculate, is going to be your $3.96, which becomes a really important number because remember, price is both in the consumer surplus formula and it's also in the producer surplus formula. So finishing up this problem, I'll do the consumer first. Consumer surplus, oh my goodness, can I just call that consumer surplus? I'm going to integrate the demand function minus the price, which I just found. So the demand function was the negative 0.36x plus 9 minus the price that I just found, $3.96. And I'm going to integrate that from, I don't know. So we'll have to, well, yes I do. 0 to 14 was, I already set the two functions equal to each other. So 0 to 14. And I'll integrate this thing. And evaluate it between 0 to 14, and I end up with $35.28. Then I'm going to repeat the process for the producer surplus. But remember, this producer surplus is going to be the price, right? Going back to this graph, the producer, start with the upper is the price minus the lower function, which is the supply. Price minus the supply function. So the price, once again, was the $3.96 minus the 0.14x plus 2. I'm going to integrate once again between 0 and 14. I'm going to simplify. I'm going to integrate and do the fundamental theorem of calculus by doing f of 14 minus f of 0. But again, I think f of 0 is just going to be 0. So all I really need to do is evaluate that function at 14. And I believe this will turn out to be $13.72. So again, you can go to Blackboard and download the PDF where we have worked out solutions. If I'm going too fast, you can rewind the video. But I would go to Blackboard and see if you can print off a blank sheet, because you can do example number 6 before I do it. And you can see there's cost 1 is the upper function, cost 2 is the lower function. I'm going to save you some video time, and there's the upper function. Here comes the lower function, and you would have to do integral of the upper function minus the lower function. It's a decimal nightmare, and it looks like I'm going to integrate this from 15 to 35. Go to Blackboard, print this off, see if you can't do it. Pause the video right now because I'll show you some answers. And again, upper minus lower. And here's the setup for that. After you do upper minus lower, this is what it simplifies to, this is what it integrates to, and after the fundamental theorem of calculus, you get 6342. The last one, number 41 on the handout, also is a consumer and producer. So you would have to set this up using the consumer, and I would encourage you to set the two functions you do together again and find out where you're integrating. Practice this, because this will definitely be on the test. And so you're going to find the point of intersection to be 80, and again, you're going to do, for the demand, you're going to do the demand function, 50 minus 0.5x minus the price. I'll let you know that x is not the price is the y value. So after you find this x value, plug that back into the function, either here or there, doesn't matter which one you go to. The p is the price, and it turns out to be 10 in this case. And then you integrate that, and then you repeat the process for the producer, surplus, and this time it's going to be the price minus the 0.125. So here, x, and then find that answer, And I think we got worked out solutions. Again, pause the video. You don't want to see this. Try to do this yourself. And that was too fast. So here are some answers, 1600 and 400. I hope this video was helpful. Please email me with your questions. Thanks.